and welcome to today's show. Today I have the pleasure of introducing Ryan Gamble from Intraratio. Intraratio is a comprehensive MES company that offers distinctive products tailored for businesses seeking to digitize their manufacturing operations. Ryan is going to enlighten us on the factors that set them apart from the other MES companies in the industry.
Welcome to Tech Talk with Trevor Galbraith, a video podcast that features industry leaders and experts from the electronics manufacturing community. Recorded at major events around the world and from the studios of Global SMT TV. Now here is your host, Trevor Galbraith.
And welcome, Ryan. Welcome to the show.
Thank you.
Yeah, so let's start with maybe a brief introduction of yourself and your role at Intraratio, because I believe you're not just the CEO, you were the founder of the company.
Yeah, thank you. I founded Intraratio in 2010, but I've got about 25 years of product and test engineering experience. So I came out of semiconductor industry, primarily central site modem chipsets, very complex, multiple DSPs, core processors, but then we had to build those into final system assemblies. And then I went on through space, military, rad hard type companies, ended up at a silicon photonics company, and that's when I spun off to create Intraratio. And the whole intent was to solve the challenges that I dealt with as an engineer and working on the manufacturing floor with operators and technicians all the way up through the executive layer. How do you get visibility of what's going on every day in real time? How do you give people access to data so that the right decisions are made, and really just about empowering people, empowering industry. And so and that was basically, we'll walk through, through some of the questions, what we've done for products that address those complexities in manufacturing.
Okay, so you obviously had a lot of hands-on experience in the field. How long ago did you start that? I mean, when did you come into that, into the industry?
End of the 90s. Yeah. So right in the big .com insanity, so went right through that big wave. Yeah.
Excellent. Okay. So we're having a look at Intraratio now. I mean, you seem to have based the company around principally three main products, which we'll go and take a look at one by one. The first of which is called Runcard MES. This system collates and manages data from standalone machines to multiple lines within one factory or across multiple factories worldwide. How does it do that? I mean, are you using PLCs or something to collect the data? How are you managing to do that?
It's everything actually. PLCs, even file data that just comes off the machine. If machines are not able to connect to the network, you can bring in a third-party single board computer, edge client, just attach to it, connect to RS-232. But basically, Runcard removes the need for third-party software and hardware in between. Anything that connects to the network, if it's old file-based data or it's a modern PLC that can do web, REST, SOAP APIs, we can plug and play with it. And we've basically been API driven since the inception of the product in 2009. It was really built around just how to get rid of third-party software and layers in between, because those are reliability points. Those are cost points. They create a lot of complexity in deployment, and that's where you get a lot of deployments that fail, especially on large-scale organizations, when you've got too many cooks in the kitchen, so to speak. So we found the way to centralize it that way.
Right. Okay. So, I mean, typically, what sort of information are you pulling off of these machines? Because there's a lot of legacy machines out in the field. So I'm assuming in the older machines, you're just pulling off what you can get, but you're probably getting a lot more rich data off of the newer machines.
Yeah, pretty well anything that the machine vendor is generating and dumping, able to put out there. We'll plug and play into it. And then what's kind of unique is a lot of these machines, they miss a lot of traceability data, right? They really focus on their specific role in the manufacturing line. So what product, what lot, what serial number, even timestamps sometimes. You see interesting things like that. And the MES will backfill that when it captures this data from the machine. We've dealt with all sorts of legacy machines, anything from 1970s metrology type equipment all the way to today's most advanced pick and place machines from Panasonic, ASM, even Ifotech, high precision laser placement on top of a chip, on top of a PCBA, that kind of thing. We can capture it all. If it's available, it's there. Doesn't matter what format, what protocol, consider it done. We'll capture it.
Right. Okay. Now, in your background, essentially, you came in from the back-end semiconductor packaging world, which is an interesting area, and you've moved into you're moving into the SMT assembly world. Both of these worlds use slightly different backgrounds. I mean, you'll find, for example, in the back-end packaging world, there's a lot of companies using SECSGEM as the backbone there, whereas in PCBA, it's mostly IPC CFX that's coming through. Are you able to deal with both of these platforms, or how does that work?
We are agnostic, actually, and so the short answer is yes, and then the long answer would be we can plug and play with any protocol, any format. To be honest, protocols and the formats that different governing bodies put out. I was part of working groups in semi-org, IEEE on certain data formats back in the day, and so I learned very quickly how how these things can be overblown. They're really solving a problem, but they try to help. They try to address too wide a range of things. At the end of the day, I was able to just see that you just need to know what the product is, what action was performed, all relevant data with it, and just send that in a standard format. So as long as you're providing core traceability, so the standards, they're extremely valuable in making sure industry is conforming to some of these key things, but they get overly expansive.
Right.
So my solution to the industry challenge of the costs involved in dealing with all these different protocols was to create one software engine that is basically a translator. And everything is just data mapping at that point. And if you need a result sent back from the MES, you can just set that. So data comes in, certain information is identified, and a result needs to go back out to the machine, tell you whether it's okay to move on or not. And in many cases, you don't want to be involved in that decision from the MES. You actually, other than just setting an alert and stopping production. So being agnostic to the type of data just really frees us up to start to do some pretty amazing things very quickly. And then the last thing I'll just say is that machine vendors are notorious for violating spec. I mean, the E142 spec out of semi, I mean, the number of different permutations we see out there from very established vendors, it's wild. So our solution has really proven itself to handle that. That's an extremely big cost. Vendor comes in and they're violating a certain part of the spec. Now you're mired in about 6 months of development, fighting with the vendor, all this. This just delays your need to get to market, your need to ramp, your need to empower your people with data. So we are completely agnostic with a pretty unique approach to it.
So am I assuming that you're storing this data somewhere in the cloud? I mean, are you running this as a software as a service system, or are you doing it with servers that are based in the factories, or does it depend on what the company's manufacturing?
No, it's basically a web stack. So it's a cloud solution from day one cloud solution, and it's installed on-prem or it can be hosted, but it's always within a company's own secure network. So security is a really big thing for us. So we have space military customers doing those type of product lines. Then we have high volume SMT, but it's a SaaS, software as a service model, but we don't host it. We can if you want, but ultimately, it's a cloud-based solution on a single Linux platform and very low cost, hyper scalable. I mean, so you can be a single line shop, high mix, low volume, or you could be Cisco, one of our customers of Molex, with 5 factory deployments all chained in, same Linux hardware, same software. You just plug and go like it's a big Lego block. So really changing it. I should actually preface why we're like that. I had the fortunate luck of running into Monty Wadenius, one of the founders, creatives of MySQL, back in 2006. And we hung out for a good part of an evening, lots of Swedish schnapps at some conference. And these guys enlightened me on how they were building out the whole back end of LinkedIn. And it was amazing with with a single stack of this software that's helped to springboard Facebook, Google, all these massive AWS. They're all using that backbone. How quickly you can move at scale and not bog down with 100-person development team. Right. So that was a very fortunate piece for me to help enable me to build up Intraratio's product.
Yeah, absolutely. No, but I mean, of course, these guys are not having to deal with things like CMMC regulations. I mean, has that been an issue for you?
Really, like we've actually had no issue on our deployments and no issues on connectivity, no issues on security. The thing that shifts is taking these massive hyperscale platforms, but then having an understanding of what the data is, what that engineering data is, what that machine data is, what the operators need, really understanding all the different user endpoints, kind of wrap it all up as a solution. And so approaching it from that perspective, no issues with different data specs. We even created our own data spec, by the way. I think it's one of the best out there, and we just give it away free. There's no licensing on it. We are not going to charge you to be the middle person broker just so that you have to pay, a whole arm's worth of, pain, deal with a whole nother server, another piece of software, another company, these type of things. Sorry, I just say our challenges are always with just really getting the vendor, the connectivity with a machine vendor. That's really the main challenge. And most of them are moving very quickly now to really share a lot more data. So
yeah, great. Okay, so let's move on then to the second component of the software suite that we're talking about today, and this is going to be Datacard. So Datacard, I believe, interfaces with test equipment on the line to provide process-related data and analytics to detect trends and possibly defects. Talk us through a little bit how this works in a PCBA environment.
Okay, so everything from AOI data to machine settings, how many cycles the laser on your laser scribe has run, all that information, it just sucks it in. So data will pass to the MES, or data can pass directly to Datacard. So the MES is Runcard, and our IoT backbone is Datacard. They're actually independent systems. So they're operating on their own servers, independent software, and they work together integrated, or they can be a standalone island, just depending on what gap an enterprise or an organization has. And Datacard in particular is basically just file-based data can show up, can be API-based, but it can capture everything and it puts it into context immediately. So it catalogs it immediately, what lot, what part, what time, what machine. It's got event data, it'll capture that, log event data, it'll capture test result, any limits, whether it's a pass or fail flag, even to the point of conditional data, as well as like what temperature was it running at, if there's humidity data, environmental data coming in. And it's all highly contextualized. So as soon as it's loaded in, you can run analytics, you can run SPC. From a board perspective, we're looking at some semiconductor wafers here, but a board is, like I look at it like a semiconductor wafer. You have a panel, you have a 4x4 panel. You want to see if you're having drift according to placement across the panel. In semiconductor, we've had those challenges for decades, and we look at that and we look at patterns across it. So what we're able to do is bring that whole semiconductor knowledge to the PCBA area and say, look, you can stack panels on top of each other digitally and see if you've got more failures located in a certain area. It's called a stack map, these type of things. So extremely formidable on all types of data on the production floor, from laser etch all the way through to final pack out.
Yeah, that's amazing. Yeah, because of course the tolerances in the semiconductor field are so much tighter than they are in PCBA. So that's certainly useful experience that you've got there.
Thank you.
Okay. So is let's see, does Datacard does it act as a storage and traceability tool? as well, or does it do corrective machine instructions, or does it just, what does it do with that information once it finds it?
It's up to how the factory wants to set it up. So what we do is we collect the data, and now we identify how it's all cataloged. At that point, the factory can now do what they want with the data. If you have the MES side, the MES has all the built-in decision logic to leverage this rich set of data from Datacard. So the MES has its basic controls, core SPC rules to apply. So you get one or two core measurements that are like the pass-fail measurements criteria, right, at a certain board step. But like a machine, an AOI, especially like an X-ray, you may have 100,000 scanned data points, right? And you can't put that in an MES, so that sits in Datacard. But now you can set up a rule in the MES that, okay, if I've got a core pass-fail signal from the machine, the board's okay to move forward, but also apply a full SPC analysis using Western Electric rules and Nelson Electric rules against the raw data, and do it across the entire lot to identify if this board actually is an outlier. Because this board, its measurement may be between the limits, but its measurement may be going way away from all the other measurements of the boards. That's something you want to stop, and you want to pull, and you want to have the data to prove it. That's what we bring from the semiconductor industry, was always looking for that anomaly. Everything's in spec so far as you think, but everything's measuring here. All of a sudden you get a measurement that moves out here. That's a nice signal to tell you may have something coming that's going to be a problem. So that's the power of what Datacard does, is probably this rich data set that now you can start to apply these rules. And if you have an existing MES, but you're missing that capability for this data aggregation, we can bring the Datacard in, and now you can start to apply those rules with the existing infrastructure you have within your factory.
Right, so you can do it across the various lines. So the SPC machines on each line, for example, you could compare against these and look for trends and outliers on that might appear on one machine.
Exactly. Yeah. Perfectly stated. Yeah.
Okay. Fine. So let's move on now to the third component, which is called ServiceCard. Now, ServiceCard, it goes beyond the factory walls to integrate with suppliers to maintain high visibility of the supply chain and the flow of materials to the factory. How do you achieve that? I mean, there are some systems out there just now at the moment, Ryan, where they've typically got APIs built into the suppliers' factories to see they can, what's available, where what volumes available, what the price of components are, et cetera, et cetera. Is that the type of thing that you're able to offer?
No, it's a fair question. We don't deal with like component procuring in terms of the integration. We can actually do that indirectly, and I'll walk through a quick example. But what we do is we plug into any and all data these contract manufacturers or these vendors are willing to share. And the key thing is some of our customers, they build their own product, but they'll ship it out the door for some other post-assembly work at another site through another company. And then it'll come back in the door and they'll finish off the product to the final system build. Basically, in essence, most companies lose visibility completely. At that point, you're dealing with email exchange. How are things? When can I expect it to show up? Can you verify the quality of the work? We kind of start to remove that by saying, if they're doing work on a machine at a subcon, they should be sharing that data with you.
Right.
Particularly if it's like test. So that data is what you can set up ServiceCard to listen for and capture automatically from FTP or API and all that. And so that's initially what it was designed to build, so that now it grabs data and actually transacts back to Runcard, the MES, saying, yes, this supplier, we see that this product has now moved through this stage, and here's the supporting data that tells you it's okay. So now you can accept the shipment back from the supplier, without going, and you have confidence. So we created this way to interchange, particularly in semiconductor, where you have a wafer and it'll move around the world, 5 different places. This one product will go through Korea, will go through Taiwan, it'll land in Thailand, it'll go into Mexico, come back here to the US, and sometimes it goes back a couple more times. It's kind of wild. So I implemented this in order to seamlessly track that. Nobody manually typing stuff into an MES. Get rid of manual transactions. We're now in the 21st century. We're now plugging and playing with data, and you take that data and say, if I see wafer data come out of TSMC, or I see a board go through Fabrinet at this stage, test data, transact it in the MES, so that I can see on my reporting that it's currently moving and it's known good. And then one last bit was where we got pulled in the financial side was that customers, we realized they were setting up alerts on our MES to tell them when boards or wafers were moving through a certain step at a CM. Mm-hmm. And then they would go and update their okay to pay PO flag in their Oracle system. And we said, why don't you just have us do that? So we just set it up that we push that data back to the MES, and we push it to Oracle, NetSuite, Acumatica, SAP, whatever it is, and your okay to pay invoice signals get flipped on, and all these other controls on your ERP. So able to fully start to really automate it. But we are that whole kind of flow. But at the end of the day, we're really focused on the quality data and connecting you to the suppliers that are doing production work for you, so that you have full reliability, control, and management of your line.
That's really interesting. So let me see if I've picked you up correctly on this. So if you can pick up the data when it initially for wafers coming out of TSMC or boards coming out of Fabrinet, you can pick up the unique identifiers for these items and then follow them through their different the whole supply chain as they go through. Would that then become in itself a form of protection against counterfeits and other sorts of issues during that product's journey?
Absolutely, that's a really great point. Yeah, we even have a serialization scheme within our solution where we can actually create a digital serial that the vendor doesn't see, right? So you have a serial number that may be printed on the board, right? But we can create up to 3 or 4 different levels of serialization. We do this for customers like Cisco, even encoding the serial so that somebody can't obfuscate it, and you can detect when you get this final product that, hey, this doesn't match. It's a little digital serial number. This is a counterfeit. Yeah, that aspect. But yeah, in essence, we create such tight control traceability that you can control, you can manage, identify whether it's counterfeit or not. We've never experienced that with our customers having their products counterfeited using our system. I've been a party to counterfeit product before when I worked with Peregrine Semiconductor. Yeah, there were counterfeit switches, RF switches being put on the market, and it's insidious. Yeah. And the pain it causes, you're processing these RMAs, they're not even your product until you figure it out, and you've burned $500,000 in engineering time at the end of it. Yeah,
absolutely. Yeah, no, it's still it was a problem that really exploded even further during COVID. So it's something that really does affect the industry. I want to take a look at. We've got a slide here that's going to show essentially all the 3 components that we've talked about: Runcard, Datacard, and Servicecard, and how they integrate. Now, I know you mentioned it a little bit earlier, but perhaps you could talk us through this slide and just tell us a little bit more about how they.
Okay. This one I love because just really full factory connectivity, and then in the upper right area you see we have this connecting to a globe, so connecting out to your suppliers, connecting to another factory, all this integration. So the 3 platforms, you bring them together, it really provides one big solid platform solution to track everything from supplier data all the way through your factory, any tooling, any machine. So AOI, SMT, backend semiconductor assembly, even reaching into semi data as well, fab data. Sometimes our customers receive chips that they're going to assemble onto PCBAs, and they want the actual source fab data that tells them how well it was performing, even into inline defect and metrology data from the fab. But here is basically inventory. So from inventory receipt, tracking to inventory loading on the machine, consuming that inventory in real time, sending the updates back to your ERP. This is what our platform can do, the MES, and then all the way through tracking now where the components in place, at what rate, how many mispicks were there, any signals detected from the machines for any issues, outlier, all the way to manual assembly. You can have an operator in front of a simple tablet, and they can have a scanner attached to it, and they can scan a barcode or RFID or just move it under a scanner, do their work and scan it out, and the MES will transact that and track it through, even down to torque tools. If you use a torque driver that's Wi-Fi enabled, connect to the Ethernet sending data, the MES can monitor that, capture that data. It can take the tool offline if it's not calibrated anymore, it's not set to the correct settings. It can take a machine offline. If the machine's not listening to a signal to go back to say stop, that's fine. The MES will put the product on hold in the MES, and once it gets to the next conveyor line, it'll stop. But basically, this full factory traceability in one platform. Again, emphasize no need for third-party software in between. Most modern tools today and machines that are deployed in the line have native data connectivity. And so we're able to connect to that, everything from inventory storage all the way to AGVs moving material. We can signal an AGV to go pick up and bring inventory to a specific location, maybe to your pick and place to load them, at least 20,000 cycles before you actually run out of material on a reel. And then all the way through the entire assembly process, reflow, AOI, AXI, all the way to the back end. So full closed loop. And you may think, wow, that's quite a big thing to take on. That's really complex. Honestly, it is, but that's really a product of working closely with our customers. My customers are so dear to me, like in terms of how fast and hard they'll push us. As soon as you bring in these tools and you're like, we can solve this, they will start coming up with more things for you to solve so quickly. And you just got to keep up and keep moving. And so we built this platform for that adaptability. Again, and not excluding anybody, being able to, on a transaction-based pricing model, where you could be a single mom and pop line, and you could have the same system as a Molex, as a Cisco systems, without having to hire IT, hiring anybody dedicated to have to support it. And it's very cost effective, and it comes up fast, 12 weeks.
Right.
Core.
Yeah. Certainly sounds a very versatile system, Ryan, and I want to thank you for showing it to us today. But before we go, one last question. I mean, as I said at the beginning, you've got a foot in both camps. You've done a lot of work in the back end semiconductor packaging side, and you're also working in the PCBA. What do you find are the key differences between both worlds?
It's really the culture, to be honest, the culture of data, but it's changing. It's moving really quickly now. It's great. So you live and breathe and die by data, because atomic deposition, we're down to like sub nanometer. Hey, did I have a particle that just landed in my junction, on my transistor? That's a molecule. I mean, craziness. But now back in SMT, you've got this complexity of integration. I mean, your EV, your car today is a rolling supercomputer, right? The amount of Ethernet control and data interchange happening on the decisions, your LiDAR, it's staggeringly complex. I was on a call a number of months ago with somebody, and I coined the term, you got billions of points of failure in your car now, right? So everybody in SMT, particularly pushing into high performance computing and automotive, this next generation automotive, we all have to think like semiconductor people now. We have to think about this high level of data integration. So, and it's changing. Some cases, I'll be honest, it's not changing fast enough, but I'm always impatient as an engineer. Right? Can always do it better, can always do it faster, but it's happening. So that cultural shift is starting to move.
Great. Well, it's certainly an exciting time to be in the industry, and as you say, things are happening, and they are happening relatively fast for our industry. They're happening really quite quickly. But I want to thank you for coming in and sharing your information today and telling us a little bit more about Intraratio.
Thank you so much.
Sure. Yeah. Okay, good.
Yeah, and just echo that, extremely exciting time. Yeah, there's so much change happening, but the product, the diversity of what we're doing, and there's so many opportunities.
Absolutely, absolutely. Great. So there we go. That's our interview for today. Of course, you'll see this interview on our website at globalsmt.net. It'll be on YouTube. It'll be on our social media channels on LinkedIn, Facebook, and Twitter. And also, of course, in all the channels that you get your podcasts on. So Apple Podcasts, Spotify, etc. Until then, the next time, I want to say thank you for joining us, and we'll see you next time.
Racing through airports, setting up show floor studios, and making sure we bring you the news from every major world event about the latest new product releases and process improvements. News from industry movers and shakers, panel discussions that get to the heart of today's challenging electronics manufacturing topics. From every major manufacturing country around the world, and even some new ones, there is only one true global source: Global SMT and Packaging.